Hello, we are the legendary Rover team from Rzeszów University of Technology. Our rover is the result of the work of 70 people from different faculties. The team consists of few sections: mechanics, electronics, science, drone, logistics, marketing, finance and IT.
The construction of our rover can be divided into suspension and wheels, frame and manipulator. The suspension of our rover is a multi-link design with shock absorbers in which we can adjust the tension of the springs depending on the mission and load. Thanks to the use of suitable filling pattern, which we compared with other versions, they provide good damping and high-frequency vibrations. Herringbone thread with a depth of 10 mm allows us to achieve adequate traction on various surfaces such as sand, gravel and stones. Thus built, the system allows us to climb hills up to 40 degrees and reach speeds up to 3 meters per second. The 5-axis manipulator of our rover is driven by 20 volts DC motors connected to 1 gears on the first 2 stages, linear actuators we built on the next 2 stages, and spare gear on the gripper rotation. Construction is made out of 5082 bent aluminum 3 mm sheets. The range of the manipulator is about 0.8 meter around itself horizontally and about 1.1 meter upwards from the frame of the rover. It can lift objects up to 6 kilograms and is able to perform various tasks such as flipping switches, pushing buttons, moving the joysticks and connecting plugs. The ends of the gripper are 3D printed and have rubber pads to better grip objects. We can also mount additional sensors and soil picker elements. To type autonomously, on the keyboard, we use mechanism called by gripper. It moves in 2 axes and pressing of the keys is realized by an electromagnet.
Stable communication with the rover is the key to completing tasks during competition. For shorter distance, up to approximately 500 meters, we use the Bullets M2 operating in the 2.4 GHz band, through which we can transmit all ROS2 system packets and digital video from 2 RunCam 6 cameras. When we exceed this range or encounter communication fail, we can switch to a satellite radio modems with 433 MHz RF transmission for basic messages. We have one 360 camera on the mast that operates using 5.8 GHz analog technology. Our drone is equipped with a video signal amplifier. This configuration allows us to achieve a range of up to 2 km. We control the rover using a custom application that provides access to all of its functionalities. The driving system is based on a differential steering controller on DC motors. Control of the drive and manipulator system is performed using an Xbox controller. Each subsystem is based on a STM32 running microROS, which connects to the Jetson and then the operations station via network. The rover has visible red emergency stop button in an accessible location, which cuts power to all modules. The electronics system and LiPo batteries are enclosed in the sealed cases that can be easily removed and replaced with new ones. This solution enables quick configuration changes depending on the competition task. Modules containing STM32s use standard nuclear boards, so we can perform easily replacement in the case of damage to a unit.
Navigation is based on the ROS2 system, which reads data from IMU sensors, depth camera and GPS. The current solution allows tracking of the rover with an accuracy of up to 3 meters. For the competition, we plan to use GPS RTK, which will further improve our precision. The AUG Pro W camera is essential for autonomy and mapping, using active stereo with an IR projector for accurate point cloud generation, even in low light conditions. Its data, combined with IMU readings, is processed by SLAM to enhance localization and mapping. Both devices connect to NVIDIA Jetson Orin via ROS2 Humble, enabling synchronized 3D mapping, obstacle avoidance, and motion planning. The detection system currently uses the AUG Light camera, DepthEye, and OpenCV to detect Aruco markers and YOLO for detection of various buttons and orange hammer.
The science module includes a gas sensor detecting biomarkers such as methane and carbon dioxide. To determine whether life is active or extinct, we use protein tests. To confirm that our scientific hypothesis is correct, we conducted a yeast test, which demonstrated a proper functioning of the gas sensor by clearly responding of the increase in carbon dioxide produced by the yeast. The depth of the sample collection will be determined by the height of the bucket that the sample will be gathered with. The height of the bucket will be at least 10 cm deep. Given that and fact that the probe is extendable and summarized depth of the measurement will be greater than required 10 cm.